How many students on yes. Yes, I can start now. Okay. Good morning, students. For today, I will continue with the lesson that we left off last week about the redshift. Um, Before I do that, I would like to review you first with the concept that we've already discussed before. Okay, so you can see here on my PowerPoint that redshift is an example of Doppler effect. We said last week, or the week, is that right? Yeah, the week before last week, that when you say Doppler effect, it has something to do with the shortening or lengthening of the light or sound waves. So we also said that if light or sound waves move far from the person or the object, the waves tend to expand. So that means that the wavelength is longer. Whereas if the sound and light wave moves towards the person or object, the waves tend to compress or become shorter. So we say now that the wave acquires a higher frequency and higher energy. Now, red shift and blue shift are two examples of the Doppler effect. So it says here, when an object moves away from us, the sound or light waves emitted by the object are stretched out. So that means the wavelength becomes longer. So if we're talking about sound waves, the sound waves, when it's stretched out, it acquires a lower pitch and moves it towards the red end of the electromagnetic spectrum. In our last meeting, I showed you how the electromagnetic spectrum looked like, and you saw that on the left side of the spectrum where you have the red color, that is the part with the longest wavelength. We call that the radio waves going to the right. So we have here the gamma ray, ultraviolet, and all other ionizing radiation where the wavelength becomes shorter or higher frequency. So here, it moves towards the red end of the electromagnetic spectrum where light has a longer wavelength. Now, according to research, we said that redshift is an indication that the universe is expanding. Now, take note, after the Big Bang, there were studies that were conducted on the movement of galaxies. Now, we said that when galaxies move far away from our Milky Way, that the light waves tend to expand. Okay, so it's stretched out. So what we have here now is that you have here, okay, your galaxy moving away. So the wavelength tends to be longer, okay? Now, most of the galaxies that scientists and researchers saw indicated that when it is moving away, okay, moving really far from our Milky Way, it is a sign that the universe is expanding. Okay, let us now go to blue shift. Blue shift is the opposite of red shift. It indicates a decrease in wavelength. Okay, decrease in wavelength. So that means that it becomes higher frequency. Okay, so you will see here The distance between crest to crest is shorter. So increase in frequency of an electromagnetic wave. Now, blue shift does not indicate the expansion of the universe. It indicates that an object, like for example, another galaxy is moving towards our galaxy. Okay? I will show you an example of this one later on. So again, I will summarize. Redshift, it indicates that the source of light, like for example, a galaxy or a star, moves away from our Milky Way. When it moves away, the electromagnetic waves tends to expand, thereby lengthening the wavelength. Okay? Now, blue shift is the opposite. So, if an object with light, like for example, another galaxy or a star, tends to move towards our Milky Way, that means that the light that is emanating from that particular object, it decreases. The light wave decreases, resulting in increased frequency. Okay, let's look at this diagram here. How does it work? Let's say, for example, we're talking of a police car. Okay? This is the person. Okay? And another person. So let's say this is person A and this is person B. Now, if the police car is approaching person B, the sound wave acquires a higher pitch. Why will it acquire a higher pitch? Because, as you can see, the wavelength becomes shorter and more waves are produced the closer it gets to the other person, to person B. Whereas, if this car, okay, is moving towards A, you will notice that the waves become longer. Okay? The wavelength become longer. So, which one here is redshift? Anybody? Does the Doppler effect redshift works on person A or person B? Okay. I will start giving the points now. Does the Doppler effect redshift works on person A or person B? Redshift. Anyone? Okay, I repeat the question again. You have a police car. The police car is approaching B. So what happens to the sound waves in person approaching person B? The sound waves become shorter. Okay, when it becomes shorter, the wavelength decreases, it acquires a higher pitch. Whereas if the car, okay, let's say this car is moving away from person A, you will notice that the wavelength becomes longer. So which of the two instances illustrates redshift? Is it A or B? Okay, let me see your answers. Okay, this is room 1, number 17, correct. It's person A. Let me see other answers. Room 1, number 10, correct. It's A. Room 7, number 40. Yes, correct. It's letter A. Room 7, number 33. Anawin, correct. It's letter A. Okay, this one answered A plus. I cannot tell. Okay. Room 4, number 4, correct. Sutipong. Your answer is correct. It is person A. Alright? Because the source of the sound is moving away from him. Now, okay, polyploid, room 3, number 29, correct. Room 7, number 19, letter A, correct. Itipat, room 4, number 29, correct. Room 1, number 14, correct, A. So room 4, number 5, room 8, number 38. Oh, it's so nice to see somebody from room 8 here. Room 7, number 17, correct. Room 2, number 12, correct. Room 8, okay, I have another from room 8, Puwana. Room 8, number 18. Hi, room 3, number 11. Let me see. Okay, correct. Room 1, number 22A. Okay, now let's move on to the second picture. This one, what do we call this one? Here. Anybody who can give me the correct vocabulary for this? What do we call this building? Anyone? Okay, I will give 2 points. This is part of your vocabulary. It begins with the letter O. Anybody? What is this object on the left and on the right side in the lower picture? Anybody can give me an answer? It begins with the letter O and ends with the letter Y. What is this object, or sorry, what is this building on the left here and on the right side? This building is used by astronomers in observing the bodies in the universe. Okay, we got the correct answer. Very good. Please show room 1, number 22. It is an observatory. Very good. Room number 1, 29, correct. It is an observatory. Sutipong, correct. Amitra, no answer. Okay, so I've got 1, 2, 3, 4, 5 correct answers. So itong correct. Room 1, number 10. It is an observatory. Right. So there is somebody looking through a galaxy. Okay, this is our galaxy. I will say it's letter G. Now, there are 2 galaxies. Okay, there are 2 observatories here. Now, in this observatory, what does it see about the galaxy? Okay, I've got more correct answers. Seta Wood, correct. Zero Pop, correct. Room 4, number 5, correct. Ploy, correct. Okay, so my next question is, what does this observatory observe about the galaxy? Is it moving away from the Milky Way or is it moving towards the Milky Way? Can you give me your answer? Charapon, correct. What is the observatory? What does the observatory observes about the galaxy? Okay, so itong you got it correct. It is moving away from the Milky Way. So this one, it illustrates what kinds of Doppler effect. Bondi Chai, correct? Who can give me the correct answer? What kind of Doppler effect is illustrated by the galaxy moving away from the Milky Way? There are only 2 choices. It's either red or blue shift. Okay, I will wait for your answers. Pacharapon, correct. Room 7, number 40. Okay, you got the correct answer. You will earn 2 points for this one. So you will see here that the galaxy is moving away from the Milky Way. And you will see here that the waves are expanding. So the redshift is an indication that the universe is expanding. Okay, I will check more answers. Bondi Chai, correct. It is redshift. Earth, correct. Soitong, correct. Redshift. Polyploid, okay. Pimada, correct. Moving away is redshift. Pacharapon, correct. Okay. Now, if this particular galaxy is moving towards the observatory, how will you describe the frequency of the light waves? Again, I repeat the question. The galaxy is moving towards our Milky Way. Take note that this observatory is on Earth, and Earth is on the solar system, and the solar system is at the far end of the Milky Way. So you have a galaxy approaching our Milky Way. How will you describe the frequency of light waves approaching the Milky Way? You use the words high or low frequency. There are only two answers. You make a choice, high or low frequency. We are now here. The light waves of a galaxy moving towards the Milky Way has blank frequency, high or low. Okay, what is your answer? High or low? Okay, I got the correct answer from Soitong. The answer is high. Room 4, number 14. Very good. Earth, high frequency. Sutipong, correct. Cream. No answer. Cream, what is your answer? Okay, we have room 1, number 10. High frequency. Panagda. Hello, not high frequency. Room 8, number 21. Pizzada. Room 3, number 21. No answer. Room 3, number 20. High. Room 6, number 26, high. Room 1, number 14, high. What else? Okay. Room 4, number 5, high. Room 4, number 26, high. Ploy, high. Zeroid. Okay, the answer is high frequency. So we said it acquires a high frequency, as you can observe, because the distance between the waves become shorter. Okay, let's move on to the next topic. Now, there is a scientist named Edwin Hubble. I do not know if you've heard about him from your previous sciences. He is an American astronomer. And there is a telescope, we call it the Hubble Space Telescope, that was named after him. He is the scientist, the first one to ever describe the redshift phenomenon. Okay, let me do some shout out for correct answers. Sirawit, correct. Pacharapon, correct. Viranpat, correct. Anawin, correct. Okay, so he was the one to describe the redshift phenomenon and relate it to what we call the expanding universe. Now, his observations was revealed in 1929 showed that nearly all galaxies are moving away. Okay. You can read this one. I have one question to ask. The redshift phenomenon was related by Edwin Hubble to what theory? Okay, I want you to read this one. This is for the reading part or the testing of reading skill in your science class. The redshift phenomenon was related by Edwin Hubble to what phenomenon? Anybody? Redshift phenomenon was related to what? Anyone? Okay, all you have to do is to read. The answer is here. When an object with light or sound waves move away from an object, we said that what happens? Okay, is the question too difficult? Again, Edwin Hubble described the redshift phenomenon. The redshift phenomenon explains to us that if an object with light, such as a galaxy or a star, moves away from our Milky Way, its wavelength expands, okay, relating it to the part of the electromagnetic spectrum, the red part of the electromagnetic spectrum that is more closely to what we call the radio waves. So the redshift phenomenon is related to what theory? What did he say? Anyone? The answer is here in the short reading. What happens to the universe if objects move away from the Milky Way? Anyone? I still cannot get the answer. What happens to the universe if the redshift phenomenon is shown? Okay, very good, Bondichai. I'm going to give you 3 points for this answer. An expanding universe. So you see, if any object with light moves away from us, again, I repeat, the wavelength of that light is expanded and it indicates that the universe is expanding. Okay, so Tipong, correct? Christoph, correct? You have the expanding universe. Okay, let us move on. Room 4, number 5, expanding universe. So this is our guy, Edwin Hubble. Okay, some shout out for correct answers. Room 4, number 5, correct. Room 3, number 20, correct. Room 7, number 40, correct. Room 1, number 30, correct. Room 3, number 18, correct. Pimada, correct. Room 7, number 17, correct. Okay. Ochara, you don't have an answer. So this is our guy, Edwin Hubble. Right. Now, I would like you to read this text. Okay? The galaxies are moving away from Earth because the fabric of space itself is expanding. While galaxies themselves are on the move, the Andromeda Galaxy and the Milky Way, for example, are on collision course. There is an overall phenomenon of redshift happening as the universe gets bigger. So, if galaxies move, that means that a collision between galaxies can occur. What is the name of the galaxy? We call it the satellite galaxy of the Milky Way that will collide with the Milky Way in billions of years. Okay, can you give me the correct answer? Students, this is for your reading skill. What is the name of the galaxy that will collide with the Milky Way? Anyone? Okay, so itong correct. The answer is Andromeda Galaxy. Okay, room 4, number 14. You got it correct. Okay, 2 points. Who is this one? Earth, correct. Christoph, correct. Right. Now, if you remember our first lesson when I met you the first time, okay, let me see. Bondichai, correct. Sutipong, correct. If you remember our lesson on galaxies, we said that galaxies are classified into 3 shapes. Do you remember what are the shapes of the galaxies? Okay, let me remind you. Okay, so the first shape begins with the letter E. Okay, the shape is like this. Loy, correct. Room 4, number 5, correct. Room 7, number 40, correct. So, I'm just reviewing you the concept on galaxy. So, we have elliptical. And then S, okay. We have spiral. And then, the galaxy that has no definite shape. It can be any shape. This one is elliptical spiral, and we have the irregular galaxy. Now, next question. If Andromeda galaxy and the Milky Way collapse, what type of galaxy will be formed? You make your choice. Is it elliptical? Is it spiral? Or is it irregular? Room 4, number 5, correct. Pacharapon, correct. Room 7, number 40. Okay, this is my next question. If Andromeda galaxy and the Milky Way collides, what type of galaxy will be formed? Is it E? Is it elliptical? Is it spiral? Or is it an irregular galaxy? Anyone? Okay, I will wait for your answer. Oh, you're still giving answers about Andromeda. Okay, Pacharapon, correct. Setawut, correct. Earth, room 6, room 1, number 17. No, Earth, the answer is not spiral galaxy. Sorry, it is not spiral galaxy. So I'm going to put an X here. So you have two choices left. Is it elliptical or irregular? Try to remember our first lesson on galaxies. There are three shapes: elliptical, spiral, and irregular. If galaxies collide, what will be the shape of the new galaxy? Bondi Chai, correct. Room 1, number 29, the answer is elliptical. Okay, you will get 3 points for this. Sutipong, correct, elliptical. Nati, yes, I know there's a bit of, okay, according to Nati, there's a bit of delay between chat. I think that is normal. Okay? So, Pacharapon, correct. Elliptical, Suksiri, correct. Soitong, correct. Suksiri, you've got no answer. Ploy, elliptical, correct. Okay. Nati, what do you mean by an it appearing for you? I don't understand. Viranpat, elliptical, correct. Kem, elliptical. CNY, correct. Anawin, correct. Pimada, correct. Okay, let's move on. So this one, this animation here is simply an illustration of the type of galaxy that will be formed when a collision happens. Okay. Now this one here is our Milky Way. Here. The appearance of the Milky Way, it depends on what part of the Earth you are looking at. If you're out there in the northern part, you will see it like this. And this is our neighbor, Andromeda. These two pictures were taken using a telescope. So this is our neighbor, our satellite galaxy, Andromeda, and this is our Milky Way. We can see it like this because, as I mentioned in the first lesson, that we are in the outer part of one of the arms of the Milky Way. Okay. Miss, I need a video. YouTube. Okay, students, wait a moment. There's a video. Wait. Okay, wait a moment. I will let you watch a video.
I think student can hear. เอ่อนักเรียนได้ยินไหมคะลูกตอบมิดหน่อยว่าถ้ามิดเปิดในนี้นักเรียนได้ยินไหม
Can they hear?
นักเรียนได้ยินเสียงไหมอ่ะไม่งั้นมิดจะได้โหลดวิดีโอให้ใหม่ตอบมิดหน่อยค่ะใครได้ยินนักเรียนพิมพ์1มาให้มิดหน่อยลูกไม่ได้ยินครับโอเค can't hear yes cannot
Hello everyone and welcome to our universe. Today we'll be answering the question, what is redshift? So this is going to be quite a quick video basically explaining what redshift really is. So astronomers often use the term redshift to describe how far away objects really are. To understand what cosmic redshift is, we must think about sound. A great example of this is a police car. You hear its siren because the waves travel through the air into your ear. If the police car is moving, then the sounds in front of it are compressed and create a higher frequency sound, and the sound waves behind it are stretched out, creating a lower frequency sound. As the police car passes in front of you, you would hear the familiar Doppler shift. Light is quite similar. It also travels in waves, and it's quite a similar process to what is happening within the waves. Light waves are able to be compressed and stretched, just like sound. But with sound, you would change the frequency, but with light, you change the colour. Blue light has shorter wavelengths than red. When an object in space moves towards us, the light waves are compressed into higher frequencies, and this is why the light is blue shifted. It's shifted towards the shorter wavelengths. But when an object moves away from us, the light waves are now stretched. These waves now go into the lower frequencies, and this is what's known when light goes to redshifted. It shifts to the longer wavelengths. So how do we calculate distance by using redshift? Well, the light from the most distant objects in our universe is redshifted, very redshifted, as seen from Earth. And this is basically because the universe is expanding. That the further away a galaxy is, the faster it is moving. And the faster a galaxy moves, the more its light is redshifted. So by measuring the amount of redshift is a great way to measure the distance of the galaxy relative to Earth. By using cosmic redshift, astronomers are able to measure the distance of galaxies as far as 12 billion light years away. With the latest technology that we have in space telescopes and ground-based telescopes, we are pushing this cosmic redshift limit even further back, looking into the deep parts of the universe and telling us really how the universe was created and how it evolved. So I hope that's given you a great insight into what is redshift. If you'd like to know any more about redshift or the expanding universe itself, I'll put some links in the description below. And as always, if you've enjoyed the video, click the like button, and if you want to support the channel, click subscribe.
Okay, I have some questions here for you to answer. Okay. To astronomers, redshift is used to describe blank. Okay, what is the answer to this question? To astronomers, redshift is used to describe anyone? Okay, you can send your answers through the group chat. Okay, Soitong, very good. When you give the answer, you don't have to use the exact words that were used in the video. You can say it in your own words. So ito ang correct. Room for number 14. How far objects are. Okay, that is the correct answer. How far objects are. Very good. So ito. Next one, number 2. When the police car is moving, the sound waves in front of it are blank, and the sound waves behind it are blank. Okay, so this is 2 points. When the police car is moving, the sound wave in front of it are what? And the sound waves behind it are blank. Okay, students, for this one, you can use the word compressed. Okay, you choose the words which you're going to use to fill the blanks. Compressed or expanded. So for the first blank, what will it be? Will it be compressed or expanded? When the police car is moving, the sound waves in front of it are compressed or expanded. Okay, you type 2 answers. And the sound waves behind it are blank. Okay. Okay, so itong room for number 14, correct. The sound waves in front of it are compressed. Compressed, it means like this. Okay, when it's compressed, the wavelengths become shorter. And the sound waves behind it are expanded. Okay, that is the correct answer. Very good, Saitong. Let's move on to question number 3. In sound waves, you can change the frequency. But in light waves, the blank changes. What is the answer to question number 3? In sound waves, you can change the frequency. But in light waves, the blank changes. What changes in light waves? Okay, let me see. C and Y, correct. Room for number 12, Pacharapon, correct. So itong Sutipong, C and Y, very good. The answer is color. Oh, okay, so I will write it here. The color changes, very good, depending on your electromagnetic spectrum. Okay, question number 4. Most of the objects in the universe are blank, showing that the universe is blank. Most of the objects in the universe are blank, showing that the universe is blank. Okay, so there will be 2 answers here. Who can give me the first word? Anyone? Most of the objects in the universe are blank. Okay, I will give you the first letter. M. Most of the objects in the universe are blank, showing that the universe is blank. Okay. Okay, Nati, correct. Moving how? Is it moving away or moving close? Moving away or moving towards to? Can you give me the correct answer? Okay, the students who said moving is correct. What is the second word? Moving away or moving towards? Anyone? Okay, the students who said moving, okay, you get the points already. Okay, Nati, correct. Moving away. Okay, very good. Nati, correct. Sutipong, you answered the second line already. Okay, Sutipong, in showing that the universe is expanding. Okay. Okay, Sutipong, you get the correct answer. You get the point. So the answer is most of the objects in the universe are moving away, showing that the universe is expanding. So itong correct. Pacharapon, correct. Wirapat, correct. Okay, so itong, your answer is expanding. CNY, correct, expanding. Room for number 5, moving away. Okay, correct. Now, for this one, I will just give you a brief introduction about the cosmic microwave background radiation. Now, if you remember the lesson on the Big Bang, you remember, students, you have a homework about this one. You're supposed to give me a work illustrating the stages that took place after the Big Bang. Now, this cosmic microwave background radiation, or CMBR, is a remnant of the Big Bang. If you remember, there is a part after what we call the explosion. So we started out with infinity. So you have here infinity, and the universe started out as a dot, and all matter and all energy is squished into this tiny dot. Okay, and Big Bang happened. Now, what is CMBR? Let's look at the first one. Point 1. The cosmic microwave background radiation is a remnant heat after the Big Bang, or an electromagnetic radiation, which is a remnant from an early stage of the universe. Now, we have here the term electromagnetic radiation. Electromagnetic radiation. The short term for electromagnetic radiation is heat. So it is a remnant heat. Now, when I go to the vocabulary after this portion, I will explain to you the meaning of the term remnant. It is also called a relic radiation. Okay? And the last one, the CMBR is a faint cosmic background radiation filling all the space. So this last part here, it simply means that the CMBR, you can find it all over the universe. Okay, this is how the CMBR looks like. It simply means it's heat. Okay, it's heat. Now, you will see here that there are parts that are blue. This is dark blue, light blue. There is a part here that is yellow and part that is red or orange. Now, these different colors in the CMBR means what? What does it mean? Does it mean that the heat is uniform, or there are parts of it that the heat is different? Okay, who can give me the answer? Different colors shown in the cosmic microwave background radiation are different. So does that mean that the heat distribution is equal or unequal? Can you give me your answer? You have two choices, equal or unequal. Okay, describe the heat distribution. Anyone? Equal or unequal? Light blue and dark blue means it's cool. Yellow is warm. Red or orange is hot. Right. Let me check the answer. CNY, correct. Soitong, correct. Sutipong, correct. So that means that CMBR does not have the equal amount of heat that is expected of it. There are parts of it that is hot and there are some parts that is cool. Okay, let's go now to the vocabulary. 3 minutes left. Okay, so the first vocabulary is remnant. When you say remnant, it is a small remaining quantity of something. Okay, like for example, this is the remnant of a cigarette. Okay, something small out of something. So this is the remnant of cigarettes. An example of the use of remnants are the following. Number 1, Joshua remained in his lab cleaning up the remnants of his scientific adventures. Number 2, their outdated attitudes are a remnant from colonial days. And number 3, if you ask tourists, the alleyways are a quaint remnant of old Chinatown. Okay. Let's look now at the second vocabulary. I think this is the last one. Component is a part of a whole thing, like this a sandwich, for example. So what is a component of a sandwich? We have cheese, tomato, veggies, ham, and so on. So we have here the following examples of component. Enriched uranium is a key component of a nuclear weapon. Revenues from oil are the biggest single component part in the country's income. So revenues is referring to money. And the last one, fresh fruits and vegetables are an essential component of a healthy diet. Okay. So that ends our online class today, and thank you for attending, and I will see you again next week. Bye.